Today we are discussing one of the most important topics in statistics, that is measures of central tendency. Whenever we collect data like marks of students, heights, incomes, test scores, the very first question is what is the central or typical value? What number represents the whole data set? To answer this, we generally use the three measures or the key measures like mean, median, and mode. In this lesson too, I'll show you what each one means, how they are calculated, and when to use them. So let's begin. First, let's start with the arithmetic mean. Arithmetic mean, first measure of central tendency. So it is defined as sum of all values divided by number of values. Sum of all values divided by number of values. Mathematically, it is denoted with x bar, and x bar is equal to sum of all values. This sign is sigma, and it tells us that add all values, and these are suppose values which are represented with x, and then divided by number. If we have n numbers, then each ith value is added from 1 to n. I runs from 1 to n. So this is the formula for the arithmetic mean. Now here is an example. This example, we have three values given, 2, 4 and 6. So the first value is suppose x1, this one. The second value is suppose x2, and the third value is suppose x3. So using the above formula, just add these values, that is 2 plus 4 plus 6, and then divided by 3, because there are only 3 values in this data set. So when you add them all and divide by 3, then you will get 4. So 4 is the central value for this data set, or typical value for this data set. So arithmetic mean is used when data has no extreme values, means not too large value nor too small value. So outlier represents extreme value in the data set. The second measure of central tendency is the median. So median is the middle value because it divides the data into two equal halves. One half smaller than the median and the other half larger than the median. So the median is the middle number, but when you arranged the data set in order, ascending order or descending order. So there are two cases for simple data. When n is odd, then median will be the middle value. If n is even, number of observation is even, then you have to take the average of the two middle values to get the median. Like in this case, if odd, suppose number of observations n is equal to odd. So in odd case, let's n is equal to odd, meaning odd number. So odd number may be 3, 5, 7, 9, 11 and so on. So median will be equal to n plus 1 divided by 2. This will give you the middle value. But what if the case is even, that is when n is equal to even number? So in this case, even number, then in this case median will be equal to average of, that is, you are taking average of two values, so divided by 2, average of one value, n divided by 2 plus n divided by 2 plus 1 observation. N divided by 2 plus 1, sorry. Plus 1. You take average in case of even number. But this is the location. Here you are locating where the median is. So from serial number, this value, average of these values. Value, and here this is the n plus 1 divided by this value. First locate the median and then pick the value from the observations. So this way you will get the middle value. Now here's the case. Example. Here the data values are 3. This is x1, this is x2 and this is x3. Now n is equal to 3 here, but you must arrange the data in any order. It is already arranged, this data set is already arranged. So let's tabulate it. So in case of tabulation, first I want serial number. So 3 values are here, 1, 2 and 3. And then observations. So we represent observation with x. x1 is equal to 1, x2 is equal to 3 and x3 is equal to 5. Now it is odd, so use this formula, the above this formula. So here median is equal to n plus 1 divided by this value, tooth observation. So 3 values are there, so 3 plus 1 divided by second, by tooth observation or value, then this is 4 divided by second tooth value. So this is now which value they are talking. So 2 ones are 2, 2 twos are 4. So median is equal to second value. Meaning that here in serial number, second value, here in serial number you will pick the second value. So this is the second value. The second value is 3. So median is equal to 3. This is the median now. Median is equal to 3. Number of observations are 3 and the median is also 3. Median can also be denoted with this symbol. This is equal to 3. So this was how to calculate median for odd observation. The next data is even observation. How to calculate when number of observation is even. So in this case, n is equal to 4. 1, 2, 3, 4, where 4 is an even number. Now arrange them as it is already arranged. So we will write serial number. So how many values there are? 1, 2, 3 and 4. Then write the values. Denote the data set with x. First x1 is 1, second x2 is, this is x1 suppose, this is x2 suppose. Sorry for my whiteboard. X3 suppose, and this is x4 suppose. Okay, first one is 1, second value is 3, which is x2, third value is 5, which is x3, and fourth value is 7. So according to the formula, average is the median is the middle value of the data set, two middle value of the data set. So you have to take the average of the two middle values. First to locate them and then to take average. So first we are going to locate it. So example median is equal to average of 1/2 n divided by tooth value plus n divided by 2 plus 1th value. First you have to solve the parentheses, okay? Then you have to add them. So when you locate these two values, you need to take average. So sample median then will become average of, now how many values there are? 4. 4 divided by 2 is second value, and then 4 divided by 2, 4 divided by 2, second plus 1, third value. So take average of second and third value. But you have to write the second and third value first from serial number. Identify the values, okay? So I'm here identifying the values. Now the sample median is equal to average of 1 by 2, whereas second value, just write the second value, then don't write second with it. Second value is 3, this 3, and the third value is from serial number you identify the values for the or from the X observations. So this is fifth value. So this will become 8 divided by 2, and 8 divided by 2 is equal to 4. So sample median is equal to 4 in this case. Now you see, then the middle value is here somewhere. This is 4 will lie here, and this is the center of the data set. Similarly, X bar is 3, and this is the center of the data set. So these formulas or these measure of central tendency gives us central value of the data set. Okay, median is useful when data has outliers. So if there are extreme values in the data set, then median is useful, but arithmetic mean is not useful in case of outliers. The third measure of central tendency is the mode. So mode is defined as most frequent value. That is, mode is the value that appears most often. So here is a data set, an example. In this data set there are 4 observations and the mode is 3 here. Why? Because 3 is appeared most often, or 3 occurred maximum number of times in this data set. So the mode is 3 in this case. So data set may have one mode, it is called unimodal, that will be called unimodal. Then if it has more than one mode, then it may be, if 2 modes, then bimodal, if more than 2, then multimodal, and if all values differ from each other, then there will be no mode in the data set. We can also graph measure of central tendency, that is mean, median and mode. So here are 3 different situations. Let's consider this first situation. This graph is of normal distribution. So if you see to this graph that is of normal distribution, then this is a bell-shaped curve. Like this is a bell-shaped, you can see it, a bell-shaped here, right? Why this is a bell-shaped? Because here mean, median and mode all are equal. So all 3, that is mean, median and mode, fall exactly at the center of the curve, exactly at the center of the curve. And we can write here that in this case mean is equal to median is equal to mode. When this is the case, that all 3 are equal, then this distribution is called normal distribution or symmetric distribution. Consider this graph. So consider this graph. So if you see, then in this graph it is not bell shaped. Here in this graph, this tail this tail is stretched towards the right side, because here mean is greater than the median. So in case when mean is greater than the median, then the distribution will be called right skew median. In this case, mean is greater than the median. Median is in the middle and mode is again at the top. So mean is greater in this case. This is right side, so larger values are on this side, and smaller values are always on left side. Now here is the third case, that is called left skewed distribution. So in left skewed distribution, mean is less than the median. So here mean is less than the median. So in such case, the tail is stretched towards the left side of the graph. Now mode is at the highest peak, median is the middle value, and mean it is towards the left side now. So mean is less than median, and if you include the mode, then it is less than the mode. And in this case, if you include the mode, then mode is greater than the mean is greater than the median, and then it is greater than the mode. Mean is greater than the median, and median is greater than the mode. So here are three graphical situations. This is one situation called right skewed. This is another situation called normal distribution, and this is third situation called left skewed distribution. Consider an example. Here in this example, the data is about test scores, and the score is out of 100. So first let's calculate the mean. So mean is 6.29 here in this case. Why? Because when you add all numbers, that is using the formula x bar is equal to summation x divided by n, whereas how many values are there? 1, 2, 3, 4, 5, 6, 7. So I runs from 1 to 7. So you have to add 7 values. So when you add all, then you get its sum 44, and then number is 7 values are there, so 44 divided by 7 gives you 6.29. so mean is 6.29. Now for the same data, find the median. So median is the middle value, but first arrange the data. So here the data is sorted, and there are 7 values: 1, 2, 3, 4, 5, 6, and 7. Then let's write the observations. So first value is 4, second is 5, third is 6, fourth is 6th, fifth is again 6, sixth is 8th, and 7th is 9th. Now as the observations are odd, so use the formula sample median is equal to size of n plus 1, so 7 plus 1 divided by truth value. We are dividing by 2 because it is the median, because we are dividing the data set into 2 equal halves. This value, so 7 plus 1 is equal to 8. 7 plus 1 is equal to 8, and 8 divided by 2 is 4th. So median lies in the 4th number using serial number, or you can say that median is the 4th value from serial number. So the 4th value from serial number, you just pick the X observation. So this is not the median, this is the location. This 4th value is not the median. It tells us that the median is in the 4th position, so, or in the 4th location. Sample median is equal to, in 4th position, you can see that the X observation is 6. So median is 6 here. Median is equal to 6. Next one is mode. So from the same data set, you just count number of repetition. So here 6 is repeated 3 times in the data set. So mode is equal to 6 because 6 appears 3 times. So mode is equal to 6. Now if you check, then mean is equal to 6.9, median is equal to 6, and mode is again 6. You can plot it. Let's plot the data set. So again, now dispose our data set for which we have calculated these 3 different measures of central tendency: the mean, the median, and the mode. Now let's plot it. So for plotting, we just draw a number line. This is a simple data, and just point out the values. So this is first, suppose this is 2. Now define equal gaps. This is 4, suppose. The next will be 6. The next will be 8. And the next will be 10. Try to define equal gaps with equal distances and equal differences. Now 4 is here. Suppose if it is repeated 1 time, then we will write 1 here. If it is repeated 2 times, then we will write 2 here. If it is repeated 3 times, then we will write 3 here. So this is 1, 2, 3. Now this is y-axis. Now 2 isn't in the data set. 4 is here. This is just 1. So just put dot here. Okay, then 5. Here is 5. 5 is in between 4 and 6. So 5 is again 1. So put dot over 5 and against 1. Then 6 is 3 times. So this is 1 time, this is 2 time, and this is 3 time. And then 8 is 1 time, and then is 9. So 9 is in between 8 and 10. So 9 is again one time, then write dot here. Now what is mean? Where is the mean? So mean is here. Or this is the mean, 6 point something, 6.29. So it is almost this 6. This is the mean. Then the median is exact 6. So this is exact 6 for median. And then the third, we don't go above this 3 because this is the height, and the height is 3 only. Sorry. And then is the mode. Mode is again 6, so you just draw double line on it. Now this is connect this line. Sorry. Now in this case, this is slightly right skewed curve because mean is slightly greater than the median. So mean is greater than other cases. You can approximate it to equal. You can say that mean is equal to median, but here 6.29, so we will consider it higher than the median. So this is how you can plot the simple data. This will be considered right skewed, slightly or little bit right skewed distribution. Right skew or right skewed distribution. Skew. Now this was all about measure of central tendency in case of simple data set. This exercise. So consider this exercise. This is the first question. Find mean, median, mode, and the data set is symmetric, meaning that you will get a symmetric shape or bell-shaped curve after plotting. This is a bimodal data set. The third is data set with outliers. So what happened? So here is the larger value, so your distribution will be right skewed. So your mean will be pulled towards the right side. Okay, and these are word problems. So these are, so try to solve these exercise. Best of luck to you. Thank you and see you in the next lecture.